Okay. Yeah. So let's start with geoinformatics, the word itself, right? So like you guys have came across many different terms such as bioinformatics, and it was quite familiar earlier also. But when I tell people that I have studied geoinformatics, people are like, what is it exactly? It's geology, it's geography, or what are you talking about, right? So basically, if you see, geoinformatics is a kind of cluster of so many different fields. So basically, when we call geo term is for location. We can say it's a geolocation, or we can say it's a special information. Okay. So now, if we will go to exact definition, then we can say when we combine remote sensing, GIS, and GPS, then what we get is geoinformatics, right? So, geoinformatics is basically, a cluster of all these three applications, or all these three kind of studies that we can say, guide you through this. So now, what is remote sensing? So we can say it's a science, or you can say it's art, because what we are doing is that we are sensing one object without coming in physical contact with that object, right? So that is the basic definition we can call of remote sensing. So now, remote sensing is a term which is very common to us, and we can simply identify phenomena which we can call remote sensing. It's not all the time about satellite images or some instruments or some scientific thing. So one component of geoinformatics was remote sensing. Another component is GIS. So what is the full form of GIS? It's a geographical information system. Now everybody know information system these days, right? So like we have different kind of information systems. We all know, you know data science, and where also there also we talk about information systems. So these days everybody know the definition of information systems. Now what is geographical information system? So as I told you earlier, that the word geo, whenever word geo comes, you should understand that it has to do something with the location. Okay, it has to do something with the geospatial data. So whenever we work with something which has location information with it, we can say it latitude, longitude, or we can say coordinates or anything. When it carries any kind of locational information, then it becomes geographical data. So to gather information of such data sets, to create such data set, or to analyze such data set, or to manipulate such data set, everything comes under GIS. Third component we can say is GPS. And this is one way is the most important one also, because see, as I told you that GIS and geoinformatics is all about location, right? So without GPS or any navigation system, where are we going to get any location information, right? So the simply when we call about GIS or any location based services, it requires GPS, or it requires any device which can gather the location information. So GPS, global positioning system it is. And another one is NAVIC. It is India's navigation system. So see, whenever we call navigation system, everybody is like GPS, GPS, GPS. But no, GPS is one of the navigation systems that we know. Okay. Now we have our own navigation system, which is designed by ISRO and other Indian organizations. So that one is NAVIC. Okay. So you can see the full form of GPS here. You can see the full form of NAVIC here. So first that we are going to get depth knowledge of remote sensing. So first question I already had asked you. Now, what is the difference between sensor and the satellite, right? So most of the people don't understand this basic thing, and so that they get confused between sensor and satellite whenever I start taking lecture. So basically, sensor is what sensor is mounted on satellite. Okay, so satellite is just a carrier to mount that sensor and to make it work and to release it in the orbit, right? So sensor is the actual thing which senses and captures images, captures data for further analysis and manipulation. So I hope you guys are now well aware of sensors and satellites, because we are going to learn types of sensors and also going to get information of different kind of satellites. So you should be clear that whatever technical things or whatever data collection task is being done by sensors, and satellites are just carriers of it, right? Now whenever I talk about satellite, mainly common people or everybody is aware of Google Earth these days. So everybody think that Google Earth is the thing from where we are getting satellite data, or Google Earth is providing us satellite imagery, or we can get satellite information only from Google Earth, right? So that is one misconception that I want to clear, that Google Earth itself is a platform which uses so many high resolution satellite to produce a clear image for all of us, right? So we will have intro of Google Earth as well. But yeah, Google Earth is not a satellite, and Google Earth is not the only archive which provides satellite images. So how do we sense it remotely, right? We are saying without physical contact and everything. So it's not only satellite that which senses, because when we come to satellite based remote sensing, uh, there are many constraints to it. There are many errors which pops up. There are many applications in which only satellite images don't work. So now let's see what other things are there. So there are basically three things: satellite images, UAVs, drones, or simple airplanes are also being used. So UAV is unmanned aerial vehicle. So when unmanned aerial vehicle we talk about, it is one kind of drone only, but there are different kind of drones in which we can say that this is UAV but not a drone, right? So that's why I've classified it differently. Also aeroplanes are being used till this date, but in some applications drones are preferred, in some applications aeroplanes are preferred, and in some applications satellites are preferred. So that we will learn in future, right? So basically when we talk about satellites, now is what happens is that when we get to know ISRO has launched some satellite, and NASA has launched some satellite, we directly don't understand that this satellite can be used for remote sensing and this cannot be used. So here clearly stated that there are two kind of satellites. One is remote sensing satellites and one is communication satellite. And as a remote sensing person, I have nothing to do with communication satellites. Okay, if you will ask some question about communication satellites, I might not be able to answer it. So communication satellites are those satellites which are being used for uh, television connectivity, or in some cases Wi-Fi connectivity. No, it's not. Because it's what I'm talking is that few people understand that when we come talk about Wi-Fi, when we talk about any GPS system, or when we talk about any communication system, it's all about satellite. So satellite communication satellites are only used for television kind of telecasting, and also for GPS use, right? GPS work on triangular satellite. So triangular satellite concept, it uses four satellite to identify one perfect location of a perfect point. So that way it uses communication satellite. What we are going to talk about is remote sensing satellite. So remote sensing satellite has a sensor which exactly requires to understand electromagnetic spectrum, right? So I think people who are in 11th or 12th standard, or I think in high school, you can understand the principle of electromagnetic spectrum. So in electromagnetic spectrum, there are different wavelengths from which we can identify the particular kind of in particular wavelength, such as from zero point 0.3 to zero point 0.6. When in this range we are sensing anything, it is called visible range. Why is it called visible range? Because this is the range from where in which we can see the features. So this all are ranges which our eyes understand, so we call it visible. Also there are x-rays, microwaves, ultraviolets. So there are different systems which catches particular kind of radiation to fulfill the kind of task it is required to do, right? So suppose if I talk about any weather satellite or meteorological satellite, then it requires infrared radiations, it requires thermal radiations, it requires microwave radiations to detect wind speed, to get the temperature information, to get the cloud top information. So weather satellites will mostly have infrared bands of the electromagnetic spectrum. It will have ultraviolet as well. And when we talk about sensor which we use for land use identification or land classification, for that I think visible range is enough. So visible range will do the task for satellites which we use for land classification and land identification. So that is how electromagnetic spectrum is important in any sensor or any remote sensing devices. Now there are two kind of remote sensing sensors. One is called active, another is called passive. So you can see the diagram on the right side, right? So passive sensors are sensors which uses sunlight. Okay, so it only reflects or backscatters. I think you guys know basic principles of scattering, reflection, backscattering, refraction, and also radiations. So this all are important physical terms when we learn remote sensing. So what optical sensors do is that they capture reflected or backscattered radiation from the Earth's surface. So when will it reflect or backscatter? When it is getting some source. So it required some source. Which source is it? It's sunlight, right? So mostly passive sensors are sensors which can be used in daytime only when sunlight is present. Active sensor are sensors which also release the radiation and get it reflected back to the sensor, right? So mainly we can say passive sensors do not release any radiation, but active sensor releases the radiation which can sense the object and get back the information to sensor. So active sensor can be used in daytime as well as nighttime and in mostly all the seasons, right? Then there are other type of satellite sensors that we can talk about is optical and microwave. So optical sensors, what all electromagnetic spectrum I talk about are part of optical sensors. It does not have any microwave sensor to capture microwave data or ultraviolet data. Now why is it required to make it differently? So when we talk about microwave data, microwave are the radiations which can penetrate through the clouds, right? So when we want to, in mostly whenever I process the satellite data, one of the most challenging tasks is to remove the cloud. And even after removing the cloud, what to do with that hollow space that created where cloud was there, right? So of course there are techniques, there are tricks from which we can somehow recover the information where there was a cloud, but it is never accurate. It is never a accurate information in that hollow space. So now whenever requirement is like, it's okay, it's a special resolution is not required, right? But we want our images cloud free, so then we use microwave, and microwave can penetrate through cloud. So in some application it's really important to use microwave, and especially when we have so many water bodies in our area where we want to get the information of. If we have so many water bodies, then it's really difficult to have images with so much of cloud cover. So in such cases microwave is being used. Now this is one of the, I think it's difficult to understand for everyone, but still I wanted to show this because this is one of the most important most important thing to understand when we have a satellite image and we actually want to get some information out of it, right? So you can see these lines shows different features on the earth, right? So when it comes to soil, when it comes to dry grass, green grass and water, which wavelength is suitable for particular land feature? So this graph is called spectral reflectance curve. So you can particularly see that water can get reflected in the green wavelength, right? Green is what? 0.4 to 0.5 is green. So whenever you have to enhance water feature in your satellite image, you have to look for green band. Any satellite image which has green band is at least required. If satellite is not having green band, then it is not useful to you. Also, uh, what we use is near infrared band for water enhancement. Because see, it's not that you will get the particular satellite image and you will get it as clear as Google Earth, right? You have to do a lot of pre-processing and post-processing to get the actual output that you might get at the end of the process. So what if we want to highlight the water feature in any remote sensing images, then you have to have particular knowledge of bands. If you have green band, if you have NIR band, then you can enhance the water by doing the ratioing process of these bands. Then there is a vegetation indices. Okay, so we call it vegetation indices to enhance the vegetation feature. So it uses red band and near infrared band, right? So you can see reflectance of green line, which is a green grass, is actually very low in red region, and it is actually very high in near infrared region. So what we do is simple ratioing: near infrared minus red upon near infrared plus red. This is the formula to get vegetation indices. So if you will understand such graph of spectral reflectance curve, then you will know which region of electromagnetic spectrum reflects the most of the radiation in which particular physical structure on Earth. So if you really want to work on remote sensing, you need to understand this, and you need to have a clear understanding of spectral reflectance curve.